Good morning, everybody. As promised, this is the extra lecture on file handling that I promised to send to all of you. So, in this short lecture, we will be dealing with how to handle files in C programs, and this will allow you to read and write to files, and we'll also show a simple example. So, uh, let's read our very normal program that we are used to we are used to writing, which is just scanning something from the user and printing it to the standard output. So scanning it from the standard input and reading and printing it to the display or the standard output. This program is very familiar. In fact, towards the end, we are coming to the kind of the first program. But let's recall a few things that we want to talk about. So one thing is that we have said that this scanf does not allow us to take in arrays or character or strings which contain the space, right? So as soon as you print in the space, you will it will just take in whatever is there till the first space. So that was one small part. The second is you're always reading it from whatever the user is entering into the keyboard. So this is the familiar program, but we are noting two things about it. One, that this scanf was not allowing us to enter spaces. That was a small thing that we will resolve as a side effect, but more importantly, we are always reading from the user, whatever the user inputs, rather than having it as something that as having something that we can read from the file. So this program, as we know, is going to read it from the keyboard and write it to the monitor, write it to the standard output, or you will see it on the monitor or your display. So in some sense, this is doing is, or internally what is happening is, this keyboard and monitor are viewed as resources, and these are actually used to interact with the user in terms of the input and the output. And files are a different way to interact with the user. That is, we can read from a file the input and write to the file an output with which we can communicate with the user. So what we want to do is first take this very simple program, make it read from a file and write to a file, and then take some small other examples. Okay, so let's first understand this program in a slightly different language. So before that, what I want to mention is that C does not provide any inbuilt functions for input output, but the standard library provides the library, in the standard library we have been using this scanf and printf, which have been implemented, and these are very useful functions for us to communicate. And this input output is performed with what are called as streams, and streams, you may be aware already, is a sequence of characters. And for every C program, we have these three streams which are implicitly available to us. These are the standard input, standard output, and standard error. Without referring to them explicitly, we have been using them because these streams are open for us. These are available for us to use whenever we are executing a C program. So when scanf is reading, it is reading from a stream which is called the stdin, and when printf is writing, it is going to write to this std out, which is again a stream, and these streams are opened for us already. So we are not doing any work in terms of opening these streams and getting handles to them and so on. But the question is, can we write or read from arbitrary streams? And that is the goal, which will allow us to interact with different files. So before we go to interacting with different files, let's rewrite this original program that we have on the first slide in a different language of streams. So for that, we are going to use a slightly different function that C provides us, which is an analog of the scanf function. So we are very well aware of the scanf function. The scanf function has the following prototype. It has the format specifier followed by the address of the variables, and there can be multiple uh, variables that you can give into the scanf function, and we have seen several usages of this. So scanf is something that we know. So then analogous function to scanf is what is called as an fscanf, and this f comes for the file part of it. So the fscanf function has the following prototype. It has a stream pointer, and we'll say what a stream pointer is. It has the same format specifier %d, %f, %c, %s, and so on, and then the address of the variable. So the remaining part is very much similar to the this the scanf function. However, we also want a stream pointer. And what is this stream pointer? It is it is of the type file star. So what is this file star? This is also made available to you. You don't have to worry about it. You, now that we are learning structures in our class, we this is some structure that is defined for us. Why is the struct keyword not there? That can be omitted by doing something what is called as a type def, so that we are going to come to in our regular classes. So don't worry about that. But this is some type which is a user defined data type, but that is being defined for you. And what you are saying is this stream pointer is a pointer to a type called file, which has been defined for us. Just like we are defining user defined types, student, point, and rectangle, and so on. So these are some things that are available to us. So the file is something which is also made available to us, and therefore we can define a pointer to this type by saying file star, and fptr is my variable name. So what I want to what I can do is okay, sorry about this. There was some network issue at the end. So, okay. So, before we give this to fscanf, that file pointer or that fptr should be pointing to the appropriate stream if we are using some file. However, in case of the standard input is always available for us, and therefore it is open for us. So this stdin is a special pointer to a file which is the standard input, and that is available for us. So when we use this fscanf, we can use it with the standard input. So what we will do is we'll slightly modify our original program to have the same thing. That is, there is a character buffer of size 100, and this is a character array, as we are aware. But instead of saying scanf % as buffer, what I'm doing is I'm using fscanf with the appropriate stream, which is stdin, and then I am saying the same thing that I had said earlier. So instead of scanf, I am using fscanf, and therefore now it is going to read it from the standard input, but I'm explicitly saying that I am reading from the standard input. So you may expect that with a similar analog, you are going to replace printf, and that is what exactly we are going to do. We are going to replace printf with an fprintf, which will again have it replaced with will have a third argument, which will be a stream pointer. So the function analogous to scanf is going, printf is going to be fprintf, and it is going to print to a particular stream. And this again, as we said, that the standard output is available for us for writing. So the printf was implicitly using the standard output. The fprintf is explicitly using the standard output by saying that I mean, we can use the standard output explicitly by saying fprintf. You can also use other streams, but for the moment we are just modifying the simple program. So what we are doing is we are taking the we are having that buffer, we are reading something from the standard input into this buffer. This part of percentage buffer is very clear to you, and we have introduced this new thing which is stream pointer. Now what you would have done with printf, what we have done earlier is saying printf percentage buffer. Instead of that, we are explicitly saying print it to the standard output, and then using two different functions which are fscanf and fprintf. So the program behaves exactly the same that as it was behaving. It takes input from the user, it prints output to your screen or monitor, but the functions that are used are different. They are fscanf and fprintf, which allow us to be aware of the fact that we are in fact dealing with two streams, which are the standard input and the standard output. Okay, so having said this, what we have done is got introduced to this notion of the streams, and we know how our the usual input and output streams behave and how to access them. Now, what we want to, okay, so I just want to mention that the standard error is by default mapped to the screen or the monitor, and therefore by default the error messages are also written to the monitor or the screen, and the other streams are appropriately mapped. For example, the standard input is mapped to the keyboard. Okay, so now with this, what we would like to do is read and write from a file. So for that, we need to be able to handle handle files and C handles files as streams. So we cannot simply say that, okay, take this file and read it unless we set it up correctly to be as a stream. Therefore, we need to open the file and open the file in a particular way, and therefore have a pointer pointing to that appropriate stream. So what we are going to do is introduce this new function which is called as fopen, and fopen has the following prototype. It takes the file name with the appropriate path. So if it is in your local directory, I mean the current directory, you don't have to worry about it. Otherwise, you'll have to give relative path or absolute path based on the directory where it is present. And then there is also a mode, and there are several modes that are possible. In the introduction part, we are just going to talk about the read and write mode, which is R and W. And the return type of that fopen function is a pointer to this type, which is called as file. So this is file star. So this is convenient because we wanted a pointer to we wanted a pointer to file star. So the usage of this is going to be fopen my data file dot text. Let's assume that my data file dot text is something that is available. And then you are saying that this is opened in read mode, which says that you are not going to be able to write it, but you are going to be able to read from it. Now this returns a pointer, and this is what we will call it as our stream from which we will be able to read and write. So let us see the usage of this with fopen and fprintf. So so let's say that we are interested in reading something from this file, which is myfile.txt. So we will open this file, which is this myfile.txt, and we are opening it in read mode, And note that we are assigning the return value to what we have called as fin. Fin is a variable of type file star, which we have defined. And of course, we have this buffer, which we have conveniently taken. And note that the file opening may not go through because it may be the case that you have given the wrong file name. It doesn't find the file to be opened, in which case fin may be set to null, or it will be in fact null. So therefore it is the caller's responsibility to check that in fact fin is not equal to null. So if fin is equal to null, then you don't want to proceed. So therefore you are not going to read it. And in this way you are just going to quit this program if fin happens to be null. If it does not happen to be null, note that because we here we should have had int main, so that it allows you to return something. So if you return from here, then you are not going to execute these lines. Otherwise, you are going to read one line using scanf, read till the first space, and then write it to the standard output. So for fprintf, we have not opened any file. We are in fact just writing it to the standard output. Only fscanf we have modified. Fscanf, for that, the first input we have taken a pointer to the or we have obtained the pointer to a file which we have opened in the read mode. So this is something that is new, where we have used this fopen function, which gets us a pointer to a file for which we are giving the name and the mode, which is the read mode. And note that the file permissions also are important, because you may or may not be able to open the file in a particular mode if you do not have write permissions. Typically files will have read permissions, so you should be able to open files in read mode. So study this program, try it out, and make sure that you understand the components of it. Okay, so this is a final modification where you are not only reading from a file but writing to another file, which is so this my file remains the same. This part is the same, but you are also having an out file which you are able to open it in write mode. So this is something that you should be able to do in your current directory. That is, you should have write permissions for that. And assuming you have all the permissions, then you should be able to open this file in write mode, which is called as out file. And it is going to open this file in write mode. You have to be careful about opening files which are already present. There are also other modes which are called as append mode and so on. We won't go into that in the introductory lecture itself, because otherwise it becomes too much to talk about several modes. But then instead of writing to std out that we were doing earlier, we are now writing it to f out, and this will take whatever you have read into this box, write it into this f out, in this file, which is outfile.txt, and you can check this out, that after this, if you open the outfile.txt using some editor, you should be able to see whatever was the word or something that you had written into the my file. However, it is not reading all the lines of my file and writing them to the output file. Note the use of fclose. It is typically a good idea to close the files that you have opened. And in fact, after this, you should not be using using fscanf or fprintf into fin or fout. So after you have closed it, you should not be using that. If you want to reread the file or rewrite it to the file, you should be opening it, able to write at the appropriate place. So what I want you to do is try out this program and see what it does for a particular my file that you have written. Write the file with whatever you want to write, and then see what is the outfile.txt. Okay, so this was the basic introduction. Now, I want to go to one another small part which is helpful in writing programs, which is the way in which you can pass parameters to this function main. So till now we have not passed parameters to main. We have always just said main into bracket, I mean main and then empty braces. That is, it does not take in any parameters. So okay. So okay, so before I go to this, I want to show this. This is the desired behavior of a thing that I want to write. That is, let us say that I have a lab8 dot text file and I want to copy it into a file called copy of lab8 dot text. So in fact, there is a Unix command which you must be aware, which says cp. If the lab8 dot text is something which is available for me, then I can say cp lab8 dot text space copy of lab8 dot text. So copy of lab8 dot text will be exactly the same as lab8 dot text. Instead of that, what I would like to implement is a function, or is a a program which I would like to call as my copy lab8 my copy program. And instead of calling cp, I should be able to say my copy lab8.text copy of lab8.text, right? So the first thing that we would like to know is, how do you rename the executable to a different name? That is easy. I think we have seen this earlier. If you use this command gcc -o, so let's say that we write a program which is called as copy program.c, and that program we have not yet written, but let's say we write the program called copy program.c, and then we say gcc -o my copy, then you will create an executable called my copy. Now, these two are some things that are parameters. These are the input, I mean the reading file from which you want to read, and the output file in which you want to write. And these are two arguments to main that you are passing. So how do you pass this is something that we have never seen, and that is what we are going to see in the next part of the lecture. So in fact, the main function can be defined with no parameters, the way we have been defining it, or with two parameters. For the one which is an integer, typically I mean, these are names that you can give. These are the formal parameter names, so you can change them. But typically, this is called as argc for argument count, the number of arguments. So this is an integer which is called as argc, and an array of character pointers typically called as argv. So again, these names are some things that you can change and modify. However, this is the standard that has been there, so that is why I'm introducing you to these concepts. So we will use these. So we'll see an example, but before that, even so, suppose you did not have these two parameters, then what you would have possibly done is possibly read the two names with scanf, the name of the input file and name of the output file, and opened it. Instead, what we are going to do is write a program which hard codes the name. So what do I mean by hardcore? Hard codes, it just puts these names explicitly. So instead of saying that earlier, what I had said is this my file.text, instead of that I'm saying lab8.text and copy of lab8. So this part has not changed, right? So this part is similar, except the names of the files have been explicitly hard coded, which could have been read from the standard input and then written here, but nevertheless that is not the important part. Now you are going to also check whether the streams that you have been returned are indeed valid streams, that they are not null. If even one of them is null, then we are going to print an error message. This printf, remember that it is writing to the standard output. You could have replaced this by saying fprintf std out, but that's okay. And then you may also want to send a return code. At this moment we are sending 0, but you want to send a return -1 or something. Okay, now what we are going to do is not read only some part of the file. In fact, we are going to read the whole file. So this function, which is fgetS, is going to allow us to uh, read from this stream. So the fgetS function has three parameters. The first is a character array or a pointer to a character. The next is the maximum count that you would want to read, and the third is the stream from where you want to read. So this fin is the stream from which you want to read. So that is opened in read mode, so that is good for us, and it is not null. It is going to read as long as one of the following things happen. That is, you reach what is called as end of file, in which case it will stop reading, or you find that there is a new line, in which case it stops. It stops reading, or it it sees that the maximum characters have been read. That is this, the buffer is only able to take in 1000. So you have read 990. Suppose you have read n-1 characters, then there is no more space to put into the buffer, because you have to terminate it with a /0. Therefore, you are not going to read any further. So one of these three things happens. It is going to terminate, and it is going to return whatever it has read. That is, whatever it has read, meaning, let's say that there is a line, this is a file, then it will read all the file till, assuming that there is a new line after this, it will read all of that file and then return a pointer to this string, which is this is a file, and therefore that pointer is not going to be null. Therefore, what we are going to do is, while we are able to read lines from this f stream, which is opened, which is available for us, which is fin, we are going to keep reading it into the buffer, and then whatever is into the buffer, we are going to put it into the stream fout. So these are two different functions which we are introducing. One which is fgetS, the other which is fputS. These are different from fscanf and fprintf. These are allowing us to read lines, and lines which also have spaces in them, and therefore this will also allow us to get over our issue that we had, that we were unable to read lines which had space. So you could have done fgetS buffer 1000 and stdin, in which case you can actually read a line which contains spaces. So that apart, once you read this line, you are going to, if it is not null, the return value is not null, that is, it has read something, then you are going to put that into the buffer, put that into the fout stream, whatever is the content of the buffer. So there are two more functions which we are introducing, fgetS and fputS, and you can also ask, are there analogs of this which are getS and putS? Yes, there are analogs of that, but it is safer to use fgetS and fgetS, especially because it takes care of this value, which is the maximum value that it can read. So you have to give it the maximum value. So the buffer has value, it has space to hold 999 characters, character array or a string of 999 length. So you're giving 1000. So as long as it reads 999, or the new line comes, or end of file comes, it will. So if one of this happens, it is going to return. Otherwise, it is going to keep on reading the characters, right? So this is a very useful function. So fgetS will allow us to read from this stream, which we have conveniently opened for this file, which is lab8.txt, and then we are copying it into the appropriately named file. So this program is fine. The only thing that it doesn't do is, it does not take in as an argument the two names, that is the lab8.txt and copy of lab8. These are still these are not arguments to main. These are in fact inputs to main, which are like you will do using you could have done it using scanf, but you are in fact hard coding them here. So now we are going to get around and use this feature of allowing or having parameters for main, which are argc and argv. And so the prototype of main will look like this. Int is the return type, which is the default return type, which we have been many times faulting. But then there is int argc, which is the number of arguments, and int argv, which is the which is a character, which is an array of pointers to characters, right? So this is something which will contain the different arguments that we want to send. Okay, so let us see first an example before we modify that program. So let us say that we are running our normal program, which we did not have any we just are running /a.out. So you compile this program. This program is written in this way, but you are not going to give any command line arguments. Then what happens? So every program has at least one input, which is the name of the executable. And this name of the executable is in fact present in what is called as argv0. So this, if you printf percent this program is always going to give you one. I mean, even if you do not send any arguments. So just write this program, compile it, and say /a.out, and we will get this. So maybe just in the interest of everybody, I will just do it on repl.it. I do not have anybody to tell me whether it is in fact sharing my screen, but I am hoping that it does share my screen. Okay, so it seemed to have, I'll just, yeah. So let me just go to this class 3 and great. So let me just make a directory for files. And okay, so as you see here, there is this program which is 1.c. I'm going to okay, so for some reason this is extremely slow. So let me see if this Vim opens. Okay, so yeah, so somehow it is, yeah, okay, great. So it has allowed me finally to, yeah, okay. The system is extremely slow. The network is extremely slow. So %d. So I cannot print arg v directly. So I'm just going to print this, and I'm just going to put a slash n here. So I hope it does compile. Okay, so this is the program which is 1.c, and if I just run a dot out, it is giving me 1. This 1 is obtained because I always have at least one parameter to main, which is this the name of the executable of the program. And if you want to print the name of the executable, then you can say that print the name of the executable is argv of 0. So argv of 0 will always contain the name of the executable, and the remaining parameters will be contained in argv of 1, argv of 2, argv of 3 as a string. And so if you want to pass parameters which are integers, you will have to convert these strings into integers. So this part I will leave it to you to try it out. And if you do gcc minus o some other name, that is you want to give your executable, then that name will be printed out when you print out argv of 0. So that is something that you should try it out. Let me see if it quickly allows me to do that. Okay, so let me just say printf %s argv of 0, and let us do this first without any change. So it should print out two things. One is the number of arguments. The second is the name of the argument. And let's say if I change this to gcc minus o my exec, this is the name of my executable, uh, 1.c, which is the name of the program. Then if I run /a.out, oh sorry, so I should not run a.out, I should run my exec, and it will print out that the name of the executable is indeed my exec. So this is something that you can try it out. Okay, good. So having said that, how many arguments can you pass to main? In fact, you can pass as many arguments as you like. And how do we access them? As I said, v of 0 is going to be the first argv of 0 is going to be the first argument, and it is always going to be the name of the executable. And the remaining arguments are there in argv of 1, 2, 3, all the way up to argc minus 1. And therefore you can print out the arguments to this program by running a loop which runs from 0 to argc minus 1 and keeps printing those arguments in this order. So the 0th, as I said, is the name of the executable. These are all strings, so all of these arguments are strings. Even if you pass 1, 2, 3, 4 as the parameters, it is going to take them as strings, and then you will have to take the responsibility of converting them. So having this feature for us, now this makes it very helpful. This was our original program where we had hard coded the names of the inputs and input and the output file. Now it is fairly easy to convert this to a program which takes command line arguments. Now we have the same program where we have the file pointers, which are fin and fout, which are pointers to the type file. And then we are checking, because it has to have two parameters. Therefore argc has to be equal to 3, because the first parameter or the 0th index into argv is going to be the name. Then the first is going to be the input file, and the second is going to be the output file. So if argc is less than 3, in fact you should say if it is not equal to 3, then you should print out this error message, which is usage my copy source file and destination file. You will see such such messages at different Unix commands that you have. This is a typical way of writing error messages. Usage is this, so please modify and use it in the correct way. And then fin, fopen, instead of having the lab8.text, we are in fact going to have the argv of 1, which is a character, which is a string or a character array. Remember, it's a pointer to a character, and that we are opening in read mode. And that is the agreement between the program and the user, that the first parameter is going to be the one from which you are going to read. The second parameter is going to be the one to which you write, and that is in argv of 2. Again, these may or may not be opened correctly. Therefore, you should always check out whether these are correctly open for you by checking whether fin is equal to null or fout is equal to null. Then it is either input or output has been erroneously opened, or it was not possible to open it. And the remaining program is the same. So there is no change in that. Once you have these two open, then you can always read from that file the way we have read using fgetS, and then we are going to put it into the buffer, put it into the fout, whatever is in the buffer. Finally, we are going to close both the streams, that is fin and fout. Sorry, that part is gone. But this is a program which almost gives you the kind of simulation of the command, which is cp file name to another file name, which allows you to copy one file into another. This is a Unix command. So we have written a C program which simulates the Unix command, which is cp. And of course, you can try to simulate a command, let's say string cat, or not string cat, sorry, cat command, which allows you to cat the file content. So let me just show you what we have simulated. So let's say that this file, which is cat1.c, cat is a command which says, show me the contents of the file on the terminal. If I do cp1.c to 2.c, then the same contents of 1.c are going to be copied to 2.c. That you should be aware. Nobody uses command line parameters, command line interface now, but it's a very, very efficient and quick interface rather than clicking around things. And so this same content has been copied into 2.c, but this we are using the Unix command, which is cp. If you write this program, my copy, the way I have written it here, then and call it my copy, then you will have the same interface, that is my copy 1.c to 3.c will do the same task that cp does for you. So in some way, we have simulated a Unix command which deals with files with a very, very short introduction to how to open files, how to close files using the given functions that are available for us. So to summarize, the learnings in this lecture are that the C treats input outputs via, or deals with input output via these streams, and there are 3 streams which are available for any C program: the standard input, standard output, and the standard error. And we can open other files for reading and writing using the fopen command. We have explored it to a very, very limited extent, which is with the read and the write modes. There are several other modes which, if you are interested, you can look it up. The fgetS and fputS functions are some things which are useful, which allow us to read and write the stream line by line. And very importantly, we have seen that the main function can have arguments, and these can be very helpful for us to pass arguments to the main and not take them using the scanf. This can be files that can be given or any other arguments, but these are taken as strings, and then it is your responsibility to convert them if you need as integers or whatever you want them to be. Okay, so with this, I'll stop this discussion on files. If you have any questions, we will take it up during our live class.